Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video presents basic concepts about probability distributions. Let's get started. So, the key concepts that we need to understand with probability distributions are first, that they give the probability for each value of a variable that is determined by chance. The variable is what is determined by chance here, not the probability. The probability is just going to be what it is. Now, some outcomes are likely to occur by chance, and other outcomes are quote-unquote unusual because they're not likely to occur by chance. So this concept that we've seen in previous mini lectures with the range rule of thumb separating out quote-unquote usual from quote-unquote unusual events is going to continue on here in probability distributions. Probability distributions have a number of different properties. You can see here on the screen a number of different types of probability distributions. We're not going to talk about all of these probability distributions in the course here, but we will talk about a number of them, the ones that are most common across multiple disciplines. Generally speaking, though, a probability distribution simply describes the probability for each value of a random variable. And often we express it in the form of a graph, a table, or a formula. The graphical, display, you call it, is probably the most common of the three. In essence, what we're looking at with a probability distribution, though, is simply a frequency distribution that reports probabilities instead of counts. So you can think of it, and in some respects, you can think of it like a relative frequency distribution. Remember where we had percentages instead of actual counts? Well, a probability distribution is much the same thing, where we're looking at a frequency distribution that reports probabilities. And probabilities, percentages are usually interchangeable. And so that's what we're looking at when we talk about a probability distribution. Now, there are some requirements that need to be met in order for a distribution to be a true probability distribution. The first requirement is that there has to be a numerical random variable x, and each of those random variables that with the values for the random variable are going to be associated with a corresponding probability. The next requirement is that the sum of all the probabilities must equal 1. And by 1, I mean 1 exactly. Not 0.9999, not 1.0001. I'm talking about 1 exactly. And the last requirement is that probability values must be between 0 and 1 inclusive. This one is actually understood because this is a property of probabilities itself, so it would make sense that the probability values for a probability distribution would conform to that property. Let's look at an example to test our knowledge of what we've just learned about the properties of probability distributions. So here we have a table showing the probability of requesting a given number of ice cream scoops when ordering a waffle cone. I knew I should have got that waffle cone from the last mini lecture. Anywho, that's going to determine whether the table describes a probability distribution. So in order to do that, we're going to run through our requirements here. So the first one that we're going to look at is that the individual probabilities must sum to be 1. The easiest way to do that is just dump your data into Excel. Because once your data is in Excel, then you can just select the cells with the probability values like you see here. And then if you look down at the bottom of the application window, you see the sum is already calculated for you. So if that number there is 1 exactly, then you've met that requirement for a probability distribution. So if it's not 1 exactly, I mean 1 exactly, what you see here is 1 exactly. So if it's not 1 exactly, then you don't have a probability distribution. there are of course 2 other requirements that we met, but you can see that those are clearly met. Each of these probability values is between 0 and 1 inclusive, and for each random variable there is a separate associated probability value. So yes, we have a probability distribution here for our waffle cones. Let's look at another example here. What is the probability that a customer will order exactly 4 scoops? Go ahead and stop the video here, try to work this problem on your own, and come back and we'll see how you did. Okay, let's see how you did with this problem. So, of course, the easiest way to answer this question, look at your distribution table. Okay, so 4 scoops right here, the corresponding probability, 0.071. Now, the other way to work this is if you have your data there in StatCrunch, you can use the custom calculator feature to calculate the same thing, but it's just going to give you the same number out as you see here in the window. So you have to first change that operator sign to equals. You put the 4 in for the random variable, and then hit compute, and then out comes your probability, which of course is the same number you see there in the table. Note the red bar there in the graphical representation for your results window. That's really important. So StatCrunch is going to color the parts of the distribution that correspond with your probability calculation. So since we want exactly 4, so it's going to be 4 and only 4, this is the only bar on our discrete probability distribution up here that's actually colored red. If we said we wanted 4 or more, then the corresponding probability would color the 4 and the 5, because 4 or more, so in everything there, 4 or less would be the 4, the 3, the 2, and the 1. All those would be colored red. So this is a really nifty feature of StatCrunch, to where when you're using these distribution calculators, you got a graphical feature up here that can give you a clue as to what probability you're actually calculating, and that visual clue can indicate to you whether or not you're calculating what it is you really want to calculate. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.